let's try to do some extra practice on some ideas of integration. For example, if I'm asking you to integrate x cubed plus 5x plus 3 all over x squared depending on x. Again, what's the first thing you should do? You have to look if it's ready or not. Well, in this case, it looks not ready. Why is that? We have a power in the denominator that can be taken up. So we can either take x to the power negative 2 up, or you can do something easily. Instead of taking it up with negative and multiply, you can just say this can be written as integration of x cubed divided by x squared plus 5x divided by x squared plus 3 divided by x squared dx. Up to you, actually. You can take it up by negative power and multiply by all the terms, or you can do this, distribute the denominator for each term. That's up to you. For me, I prefer this one. So, of course, you can do long division since the power of a numerator is greater than power of denominator. So there's more than one way to simplify. In this case, this will be integration of x plus 5 over x plus 3x to power negative 2. I will take it up just to make it ready all at the same time. Now the function is ready. Integration of x is x squared over 2. Integration of 5 over x is 5 ln absolute value of x. Integration of 3x to power negative 2, 3x to power of negative 1 over negative 1 plus c, and of course you can simplify this. Okay, this was the first idea that I wanted to introduce here. The second idea is, let's say, example, integration of 12x squared over 2x plus 1, depending on x. Well, this one is a little bit different. In this case, I cannot distribute the denominator. So what can I do? We notice that the power of numerator is still greater than the power of denominator, which means I can use long division. So let's do long division. 12x squared divided by 2x plus 1. Divide, that will give you 6x, multiply 12x squared, 6 times 1, that's 6x. Subtract or switch the signs. Minus, minus, this will be cancelled. So what's left here is negative 6x, continue division. Negative 6x by 2, that's negative 3. Multiply, you'll get negative 6x minus 3. Again, switch the signs. Cancelled, the remainder is 3. Now, how would that help me in the integration? Now, instead of having all of this expression, we have the answer of integration. We have the answer of integration here. So the division is equal to 6x minus 3 plus the remainder divided by the divisor. So my integration will be now, my integration is now integration of 6x minus 3 plus the remainder over the divisor 2x plus 1, all depending on x. Now my integration is ready because I know how to integrate 6x, I know how to integrate negative 3, I know how to integrate 3 over a linear function. So immediately this will be 6x squared over 2 minus 3x plus 3 ln absolute value of 2x plus 1, and of course don't forget to divide by 2, all plus a constant c. Okay, is that it? Actually, integration is full of ideas. There are many ideas. I'll try to introduce this one for you. Let's say we have integration of 1 over 1 plus radical x dx. Okay, in this case we have radical, but we can't take it up because it's in denominator and there is an addition here. So what am I gonna do? I'll remember the keys that I told you about choosing the assumption, and keep in mind that these were keys. So these are not rules. These are just to help you in thinking how to choose an assumption. So in this case, I will try to choose the denominator as u. So u equals 1 plus radical x. What will that give me? Derive. Integration of 1 is 0. Integration of radical x, that's a special case. So derivative of what's inside over 2 times original. Or you can apply the power rule to the power of half, up to you. When you cross multiply here, you will get dx equals 2 radical x times du. Let's take this to our integration and see what's going to happen. 1 over 1 plus radical x, that's u now. 1 plus radical x is equal to u. So u times dx, which is now 2 radical x du. There is a problem, and we have introduced this problem before, but in a simpler question. We have 2 radical x that cannot be simplified with anything. So what should I do? If you remember, I talked about such an idea before. We have radical x here, so solve for radical x. What will you get if you solve for radical x? Move 1 to the other side. That will give you radical x is equal to u minus 1. So you can replace radical x by u minus 1, and you can take this 2 out, of course. So what will happen if you do this? It will be equal to 2 integration of, instead of radical x, we have u minus 1 divided by u times du, which looks like the first example that I've introduced here. Right? We can distribute the denominator. So again here, I can distribute the denominator. So 2 integration of u over u minus 1 over u, all depending on u. So this will be 2 integration of 1 minus 1 over u du. Now it's direct and ready. So it's 2 times integration of 1, which is u, integration of 1 over u, which is ln absolute value of u, or plus c, and then you just replace u by its value. So 2 times, and u was 1 plus radical x. So 1 plus radical x minus ln absolute value of 1 plus radical x, absolute value, all plus c. Well, I hope that these examples help you to think, and remember that I gave you keys before to help you in thinking, but these are not rules, so you have to think on how to use them. I hope that this was clear.